So, we had started in the last class the EV storage. What kind of batteries are used and what are some of the key important aspect when you start looking at the batteries. We had looked at, and I am just very briefly review at some of the important parameters that govern how good a battery is. For example, the first thing that you have to ask about the battery is what is the capacity of the battery, and the capacity of the battery is given in Ah, which is a battery AH multiplied by the voltage which it uses actually gives you the battery watt hour, the total capacity of the battery. So, this is the first thing that I talked about. Then I talked about state of charge of a battery. At any point of time, what percentage of the battery is charged. When it is a 0%, basically means battery is completely discharged, and when it is 100%, it is fully charged. As we will see later on, we never let the battery go to 0%, we never let it go to 100%. In both the cases, it hurts the battery life if we do that. So, the output voltage, if I take a 48 volt battery, will vary depending on the state of charge of the battery. It can go down to as low as 43 volt, depends on the way the battery is designed when it is a 0%, and can go to 55, 56 volt when it is close to 100%. So, this is what we have to all the time looking at. There is a very important concept that I have been talking about repeatedly, the C rate of the battery. It is defined as how many C, 1 C, 2 C, 0.5 C. 1 C charging or discharging rate basically means the battery could be charged from 0% to 100% SOC in 1 hour. So, that is the 1 C. 2 C basically means half the time, twice that rate. So, actually you can charge from 0% to 100% in 30 minutes, and 0.1 C will mean it will take you 10 hours to charge from 0% to 100%. Now, the battery may not be 0% to start with, and you may not want to charge at 100%. Well, then it will change, but if the C rate is defined in that manner. So, for example, if it is a 15 kilowatt hour battery, 1 C charge will be at a charging rate when the power input or output is 15 kilowatt, and at 30 kilowatt charging rate it is a 2 C charging. I had talked about how is the capacity of the battery affected, and we said there are two important parameters that impacts the capacity of the battery. One is aging with time. As time goes on, the battery capacity will slightly deteriorates, does not do too much, maybe 1% a year, maybe even less, but if you leave the battery, it will deteriorate. Similarly, each time you charge the battery, discharge, this it is called 1 cycle over, the battery capacity slightly goes down, and battery is defined as, let us say 2000 cycles, it will go from 100% capacity, a new battery, to 80% capacity, means the battery capacity has gone down to 80% of the initial capacity. Now, very often when the battery capacity goes down, of course, it implies that your range that the battery can support for the vehicle will also go down. So, very often you do not want to continue to use it. So, very often for a vehicle, end of life can be 80% of the initial capacity or maybe 70% of the initial capacity. So, the end of life is a very important, and that depends on the user sort of saying, now I do not want to work with limited range, I would rather replace the battery. So, 15 kilowatt hour battery to begin with, at 80% basically once it reaches 12.5 kilowatt or for example, with 70% end of life, at 10.5 say battery is no longer usable in electric vehicle. So, this is the battery capacity that we had talked about, the voltage into Ah by 1000 in terms of kilowatt hour. Okay. Then we introduce a concept of depth of discharge. Remember, we said we do not want to charge it to 100% or to 0%. So, the question is, how far up are you willing to charge? How far low you are willing to discharge? And that depends on a parameter called depth of discharge. For good life of the battery, you do not want it to be 100%, you probably have 85%, 90%, depends on the battery. And you may want to never reach the top, maybe 90%, maybe even less, and similarly do not go to the bottom. You want to leave X percent of the total energy is the usable energy, and some not at the top, some not at the bottom. And if the end of life, when the battery capacity remaining or state of health, it is the concept of state of health is y%, that means battery's initial capacity has gone down to y%, that is the battery life, then the battery life may be over. So, actually the energy available for you at the end of life is only X% of Y% of the C, and this is what I had told you. So, if you make it end of life as 80%, 85% depth of discharge, you are actually at the end of life, the battery capacity is only 0.68 C. So, if in the beginning it gave you 100 kilometers, now it will only give you 68 kilometers. So, you must keep that in mind. You must keep in mind the end of life, and you must keep in mind the depth of discharge. All right. There is a second life of the battery, that after the battery capacity has gone down and you no longer want to use in electric vehicle, you can still use it somewhere else. For example, in fixed application where you do not mind the battery size to be a little larger. So, you may actually keep it, and for example, UPS and all that. And of course, I had mentioned that aftermath of second life is you want to recycle. We will come to that later on. Then I talked about that how battery pack is made using battery cells. I am revising what I had done in the last class. Life of battery pack is primarily dependent on the life of cycle of a cell. So, the cell, and every cell matters. If there are 100 cells that will go to assemble a battery, if one cell goes lower, the whole battery pack goes lower. So, it is the cycle life of battery cell is a fundamental parameter depending on its chemistry and other factors, and normally defined by the manufacturer. But then I talked about that it is not an absolute number. The life of a cell depends on the rate at which it is charged and discharged. So, C rate of charging. It depends on the temperature at which it is charged and discharged. I had talked about that 25 degrees centigrade is the best temperature for lithium ion batteries. You charge it higher, the life cycle goes down. You charge it lower, life cycle goes down. So, it will also depend on the C rate. Depth of discharge, if you try to use 100% depth of discharge, the battery life will significantly go down. So, you tend to leave something at the top and the bottom that improves the life of the battery. So, most lithium ion battery performs best at 25 degrees centigrade, you will say at 0.1 C, but that is very low rate, you will actually use it more, higher rate. To that extent the life cycles will go down. When the battery charge is between 10% and 80%, so only about 70%, that is the best. But now you have to reach a compromise. This will mean the battery actually will be used only a limited extent. So, lithium ion manufacturer may guarantee that 1000 cycle, if you charge at C/2 rate at 25 degrees centigrade at 85% DOT. This is what a manufacturer may give it to you. and now you have to interpret, no, I do not want, I would like to do 90%, so how much deterioration will take place, and if I want to go off from 25 degrees centigrade, how much deterioration will take place. So, as I told you, one of the biggest problem is rate of charge discharge. If charging and discharging is done at higher rate, it impacts the life of the battery, and the life of the battery really goes like this. So, at 0.5 C and 1 C, it can give you a decent life. You start charging at 2 C, 3 C, or discharging at 2 C, 3 C, it hurts. The charging hurts more, discharging once in a while you can go at higher rate. Charging you like to do at 0.5 C or lower. If I look at it, here is a cell, and at different 2A, 10A, 15A and 20A, the life cycle very quickly goes down to 80%. It can do 400 cycles, less than 400 cycles at 20 ampere. At 2A, it probably can do 1000, 1500 cycles. So, this is something that I talked about. Then I sort of said that higher temperature impacts the life of the battery, lower temperature affects the life of the battery, a minus temperature does impact the life of the battery. You like it to operate probably between 15 degrees and 35 degrees centigrade. Again, it will depend on battery to battery. You may buy from manufacturer 1, who may say this is the optimal place, another one will say another optimal place is something else. Depth of discharge, 100% gives you very few little cycles, 80% give you good cycles, but 75-85% will also give you a decent cycle. So, typically 80 to 85%, they are good quality battery, which you can have 90% depth of discharge and still works all right. So, I talked about that you leave the window at the top or at the bottom. I talked about, I am just repeating it, I am not. So, to sum up, we talked about battery capacity and battery costs are the two important parameters. It will depend on the battery life, because finally usage cost depends on the battery life, and the battery life itself is dependent on rate of charging, discharging, temperature, depth of discharge. We also defined other parameter like state of charge, depth of discharge, end of life, C rate, cycle life, aging, etc. Having had done that, now I will come to what I wanted to teach today. Why do we prefer using lithium ion battery? Lithium ion battery has become more or less the battery of choice for all electric vehicles today, and what is the reason? So, let us look at the battery history. The first important thing, is it a one time charged battery? You buy a battery, normally we buy for a torch, a pencil cell or a slightly bigger cell. Once it becomes bad, you throw it away. That is a one time charge. It actually comes to you charged from the factory, and you cannot charge it again. As opposed to that, there is those kind of cells are no use to us in electric vehicles. We want rechargeable. Even in cell phone, I want rechargeable. One time charge ones are of no use. I do not want to change cells all the time. Laptop also, you want rechargeable cells. So, the rechargeable cells are called secondary cells. One time charge are the primary cells. The secondary cells itself, it started with nickel cadmium. 25 years back, we used to have in rechargeable, we used to have a camera in which you put a rechargeable battery. There are other devices, you put a rechargeable battery, and that used to be nickel cadmium. It grew to nickel metal hydride, then lead acid became very useful. For example, UPS in India, most of them have lead acid batteries, and then came lithium ion, and we are starting to talk about other lithium ion technology, lithium ion polymer, solid state lithium ion battery. They are all variations of lithium ion batteries. Now, why did this come up and what does it really mean? I also am showing you different kinds of battery. There is a battery pack like this. There are cells which are like a coin cells. there are different sizes and things like that. What determines, what do you say, what is a desirable specs for the battery? What are the things that you would really like to look at? Of course, since we are talking about larger battery, see in a very small battery it did not matter as much. The cost will be one of the most important factor. If I want to buy a 20 kilowatt hour battery, how much will it cost? Cost per kilowatt hour is a very important parameter. And cost per kilowatt hour was very high at one time, it has gone down. There is a cell cost and there is a pack cost. And the pack cost of course depends on the cell cost, but pack cost is cell cost plus extra. We will get into it. One of the parameters that makes most difference is called specific energy density, sometimes also called gravitational energy density. It is defined in terms of watt hour per kg. Why? Because almost all the items which use rechargeable are something that you carry along. Your cell phone, your laptop, even your camera. So, since you carry it along, question is after one charge, you want to see that how long it lasts. So, you want a slightly bigger cells. But the question is how much will it weigh? Will the weight in the cell phone become so large that I won't like it? Cell phones beauty comes from its lightweight. You will say, does it, for a vehicle it matters? Well, it does, because it weigh the cell size, the pack battery pack is very large, 20 kilowatt, 30 kilowatt hour. So, the weight will become very large, and if the weight of the vehicle increases, its usage of power increases, the battery, you will either have to put larger battery, which will again increase the weight of the vehicle, or it will go smaller range. So, weight makes a huge difference. The second reason weight makes a difference, because the weight is a reflection of weight of the materials that you use in the battery. And as I had talked to you earlier, in lithium ion batteries the primary material is lithium, manganese, cobalt, nickel and graphite. These are expensive materials. If you use half as much, if watt hour per kg doubles, you will use half as much material as you would have used when it was not doubled for a same kilowatt hour battery. Now, half as much material usage almost will half the size cost of the battery. So, cost of the battery is very dependent on energy density. So, this is one of the most important parameter driving the new research in the battery. You want the cost to come down, and therefore, you want higher energy density. Volume energy density, how much, what is the size? Even if weight is one part, the size becomes another. You do not want your cell phone to be too bulky. Even for a two-wheeler, if the size becomes too large, you can't put it those space to put it in there. The third important parameter which I have been talking right from the beginning is the C rate. What is the number, sorry, life cycles at certain C rate, at certain temperature, at certain depth of discharge. Life cycle will mean not just the cost, how long will this battery pack last, because after that you will have to replace it. So, that becomes an important parameter. Of course, the capacity and depth of discharge usable becomes important, C rate usable, safety and safe disposal. So, these are the parameters which defines electric vehicle. Battery of course is selected to match the vehicle requirement. If a vehicle requires 20 kilowatt hour for a certain range, you have to have 20 kilowatt hour. So, battery selected to match the vehicle requirement. It has to match it in two ways. One, it has to match in terms of instantaneous power. If battery suddenly needs say 40 kilowatt. If you have a battery which is 10 kilowatt hour, it means it will require 4C, and that is not good. You will have to have a minimum size of the battery to be approximately 20 kilowatt. And it is the motor guys who will tell you what is the power required. So, power required, instantaneous power required influences the C rate and the capacity of the battery. And of course, weight and size becomes a very important component, as I talked about. Capital cost becomes very important, life cycles become very important, because capital cost has to be divided by life cycle, number of years that I can use, that is one. Second, you have to take into account the interest rate, we will come to that later on, because if you have borrowed money, it will mean that you are going to pay interest. An extremely important parameter is time to recharge the battery. I have run out of battery, I go connect it to the charger. Can I charge in 10 minutes? Can I charge in 5 minutes? That would be ideal. I normally fill petrol in 5 minutes. I can charge in 10 minutes, well, I may be willing to wait. What if I can't charge in less than 1 hour? That becomes tough. Either I have to wait for 1 hour, or there is a very interesting, when you go forward, you will see a Japanese standard for a charger is called CHAdeMO. CHAdeMO. CHAdeMO is standard for the charger battery. Actually, if you look at the word, you see, well, I have put it on charger. Let us go to have a cup of tea and come back. Cha comes from the Japanese word cha, and Indian word chai may be the same. Demo, basically let us go for and have a cup of tea, or even more. Will it take 2 hours to charge? Then even tea you cannot go. Can I do partial charge? All those issues will come. Does it take 4 hours to charge? Remember, charging in 1 hour is 1C, and I had said not the best for the battery. 0.5C or 0.3C would have been good for the battery, which means 3 hours charging or even 4 hours charging would have been good for the battery. But maybe you have to charge sometime in 1C. Sometime you have to charge faster than 1C, 2C, which means in half an hour. The question that you will ask, can the battery withstand that? What will happen to the life cycle of the battery? And then of course, you have to have a charger at higher charge rate. So, these are the questions, we will get into depth of these things. Let us look at the batteries that I talked about, the historical battery. If I look at it, there was a lead acid battery, still commonly used. Nickel cadmium, almost going, and metal hydride. It used to be there in your calculator, for example, used to use these batteries a lot, rechargeable batteries. Camera used to use. And then there are lithium ion batteries, and lithium ion also there are 3 kinds that I am saying. There is a phosphate batteries, there is a, we will get into more detail, there is a cobalt based batteries and manganese based batteries. Look at the first parameter here, watt hour per kg. It has been evolving, and lead acid is only 30 to 40, 50 watt hour per kg. Which means not only it will be heavy, but also it will use lot of materials. Nickel cadmium went a little better, nickel metal hydride did a little better. Then came all this phosphate, manganese, and now cobalt, 250 watt hour per kg. Actually, this is the old data. We have now crossed 300 watt hour per kg. 300, yeah. So, this is what I am saying. We have crossed 300 watt hour per kg, extremely important. What will happen? Now, my weight of the battery reduces. If I use, instead of 300, if I used 30, my battery weight would have become 10 times. So, we want to use 250, 300. These are, by the way, for the cells, not for the whole pack. Pack may have some extra weight, and we will figure out how much. So, it also means at 300 watt hour per kg, the cost comes down. If I use, for example, lithium phosphate, suppose it is 100 and this is now 300, my cost will be approximately 1/3. And that is the reason we used to have $1,000 per kilowatt hour, and it has gone down to almost $100 per kilowatt hour. This has happened primarily. The most important parameter is specific energy, also called gravitational energy, and it is this which will drive the future batteries also. We will come to that. Internal resistance, we want that to be low, because otherwise that much heat will get dissipated. Cycle life, we want the cycle life to be close to 2000, at least 1000, 2000. So, this is not entirely correct. The cobalt NMC battery today will give you close to 2000 cycles, and even 5000 cycles. There are battery which gives you 5000 cycles. Charge time ideally is 1 to 2 hours, 2 hour, 1 hour occasionally. They impact the life of the battery. There are of course other things, overcharge tolerance, self discharge. Self discharge for lithium ion battery is low, 5%, 2 to 3% per month, means you have left the battery on charging, charged battery, end of the month it may be 97% or 95%, not too bad. Of course, you can charge it. Cell voltage, charge cutoff, all this plays an important role. Temperature -22 plus 60 degrees centigrade, charging temperature 0 to 45, this play an important role. Maintenance free, of course, we are only talking about maintenance free battery. Earlier batteries did have maintenance, and these are the dominant batteries that are used now. Toxicity of lithium ion battery is low compared to the earlier ones, but even then you should recycle, because material cost is high. If you recycle, you get back the material. So, well, cost is considered high, but it is actually falling down very rapidly. Battery chemistry, most popular battery chemistry, this is what I was pointing out. It used to be close to 1000, this is $500, it was even higher. In 2010, it was $1000 per kilowatt hour. And if you see, this is going down, it has come down to $100 per kilowatt hour. It has already reached $100 per kilowatt hour at cell level. Lead acid battery, on the other hand, is reasonably expensive comparatively. Well, it is not as expensive in terms of actual cost, it is less, but the number of cycles that it gives you is very little. So, it ends up being very expensive. So, lithium ion battery cells emerged somewhere here, and since then it has become the dominant thing for cell phone, laptops, and the cost has been coming down as the energy density keeps on going up. Okay. This is again telling you the same thing. Look at from 2011, we started with 80 watt hour per kg, we have gone to 300, see the cost from $800 has come to $110. So, today we have 250 to 300 watt hour per kg. Now, there are promises that if I take NMC battery, but if I put graphite and silica anode, in a few years I may get to 400 watt hour per kg, 500 watt hour kg. Volumetry energy density is already touching 500 watt hour per liter. Remember, these are for the cells. For the pack, depends on people like Dr. Kaushal. There are people who make it such that the pack is only 20% more than cells, 25% more than cells. There are others who make it 2 times the cell weight. or volume, then it becomes a big problem. So, as I point out, cost of battery is inversely proportional to energy density, and it is the main driver for cost density reduction. A high energy density batteries today use lithium, cobalt, nickel, manganese and graphite, and all of them are expensive material.